Alright, page 2, number 14. They're telling you that the two triangles are similar. That means that all the angles are equal in each triangle and all the sides are proportional. I am looking at the two sides DE and side AB that each have a measure. That tells me that my similarity ratio is 20 over 15, which if I divide each by 5, okay, my similarity ratio is 4 to 3. That means all the other corresponding sides have to have the same ratio. If I'm looking at x plus 4 and the corresponding side 12, x plus 4 over 12 has to equal that similarity ratio of 4 to 3. Now this looks just the same as numbers 1 through 3 on your review. So you are going to cross multiply like we did before. 12 times 4 is 48. 3 times x plus 4, don't forget to distribute the 3 to both the x and the 4. Subtract 12, you get 36 equals 3x, divide by 3x equals 12. If I'm solving for y, I'm comparing y, or side FE, with side CB. Okay. The ratio of y minus 1 over 9 also has to be equal to the scale factor or the similarity ratio of 4 to 3. Cross multiply again. You get 36 is equal to 3y minus 3, distributing the 3 to the y and the negative 1. Add 3 to both sides. 39 equals 3y. Divide by 3, you get y equals 13. Okay, number 15. They're actually only giving you the angles. They told you that n is 130, m is 4x minus 2, angle y is y plus 41 degrees, and angle x is 50 degrees. Well, if two shapes are similar, you know that all the angles in both are congruent. So if we know n is 130, then I also know that y is 130. So this angle right here is 130. And then I know if x is 50, m is 50. Now to solve for x, since I know that m is 50, I'm going to set 4x minus 2 equal to 50. Add 2 to both sides. 4x is equal to 52. You take 52 and divide 4, you get x is 13. So you're not setting up a proportion when you're dealing with the angles, because the angles in each shape are congruent. You only set up a proportion when you're talking about the sides. Alright, y plus 41 must be equal to 130. So if you take 130 and subtract 41, you get y is 89. Alright, number 16. Each pair of figures is similar again. So again, similarity means the sides are proportional and the angles are equal. If I'm looking at my two shapes, the only sides that actually have two numbers that go together are 24 and 18. That means my similarity ratio is 24 over 18. If I simplify that ratio, you get 4 over 3. So 4 over 3 is your similarity ratio. That means that the ratio of 10 over y minus 6 has to be equivalent to 4 over 3. Cross multiply, you get 30 equals 4y minus 24. Add 24 to both sides. 54 equals 4y. Divide by 4. Y is equal to 13.5. You can solve x the same way. 26 is matched up with x plus 2. So 26 over x plus 2 must also equal the similarity ratio of 4 over 3. 26 times 3 is 78, and that needs to be equal to 4x plus 8. Subtract 8 from both sides, you're left with 70 is equal to 4x, and divide by 4, x is equal to 17.5. Alright, number 17. We learned that there was a quicker way to set up a proportion as long as you knew that this segment was parallel to this segment. Off the bat, by looking at the picture, it doesn't tell you that these two are parallel. However, because you know that this angle right here is congruent to this angle because they're both 90 degrees, let's take a look at those two lines and this transversal right here. Since these two angles are congruent and they're both corresponding angles, that allows us to know that these two lines are parallel. So since these are parallel, we can use the shortcut that tells us that 6 over 4 is equal to 3 over y. That would leave us with 12 equals 6y, and y is equal to 2. To solve for x, you're going to have to do things a little bit differently. You know that this whole side is 10, 6 and 4 together. And now that you know y is equal to 2, you know that this whole side is 5. So if I redraw that big triangle, I have this side is 10, this side is 5, and I'm looking for x. The Pythagorean theorem, since you have two sides of a right triangle, will help you solve for x. X squared plus 5 squared is equal to 10 squared. Remember, 10 is the hypotenuse because it's across from the 90-degree angle. That leaves you with x squared plus 25 is equal to 100. Subtract 25 from both sides, you're left with x squared equals 75. Take the square root of both sides, x is the square root of 75. But from here on out, you shouldn't be leaving your answer in terms of a square root if it can still be simplified. The square root of 75 can be written as the square root of 25 times the square root of 3. This is the highest perfect square that goes into 75. The square root of 25 is 5. So your answer in simplest form is 5 square root 3 for x. 18. Okay, this goes back to that same rule. They tell you that these are parallel. That allows you to say that 8 over 6 is equal to 3x over 6. That's the shortcut. That's the shortcut you use for the parallel lines. Okay, so then 8 times 6 is 48. And then 6 times 3 is 18. Okay, 48 divided by 18 is going to get you x is 2.67. Now to solve for y, again, that's going to be a little bit trickier, because y minus 1 is the side of the small triangle, and 10 is the side of the large triangle. So before, when we did solve for x, this was a side over a part and a side over a part. That's why it worked. Here you need to do the whole side over this whole side, and you're going to need to look at the side of the small triangle and the side of the large triangle. I'll draw the two separate triangles just to make it a little easier to see. 8, 3x, y minus 1. The big triangle, we know this is 10, and we know that this side is 14 because it's 8 and 6 together. So if you're looking for solving for y, you're going to use the scale factor of 8 over 14, and that has to be the same ratio as y minus 1 over 10. You cross multiply like we've done before. 8 times 10 is 80. 14y minus 14. 80 plus 14 on both sides gives you 94 is equal to 14y. And then 94 divided by 14 y is equal to 6.71. Okay, number 19. You've got the parallel lines again, which allows you to do the shortcut. This proportion, or this part over this part, so that ratio has to be the same as this part over this part. So you've got x minus 4 over x minus 5 has to equal x plus 1 over x minus 6. This is definitely one of the harder proportions because when you cross multiply, you're going to have to FOIL. X minus 4 times x minus 6 is equal to x minus 5 times x plus 1. So when you FOIL the first, okay, you got x times x, which is x squared. X times negative 6 is negative 6x. Negative 4 times x is negative 4x. And negative 4 times negative 6 is a positive 24. On the right, you're going to have to FOIL this too. X times x is x squared. X times 1 is 1x. Negative 5 times x and negative 5 times 1 gives you negative 5x and negative 5. On the left-hand side, I'm going to combine like terms. Negative 6 and negative 4 is negative 10x. Okay, so on the left, I'm left with x squared minus 10x plus 24. On the right, I am also going to combine like terms. 1 minus 5 is negative 4x. So on the right, I'm left with x squared minus 4x minus 5. I'm now going to get everything to one side so that I set it equal to 0. If I subtract x squared from both sides, the x squared is going to go away. I am going to add 10x to this side, add 10x to this side. It's gone on the left, so I have 24 is equal to 6x minus 5. And then if you add 5 to both sides, I am left with 24 plus 5, which is 29 is equal to 6x. 29 divided by 6 gives me x is equal to 4.83. Alright, the last one on page 20. You have an angle bisector. So in our notes, if this is an angle bisector, we know that these two are equal, and the ratio of A over B is going to be equal to x over y. Here they're telling us we have an angle bisector, just like we've done in our notes, but it bisects the right angle of a triangle. So this angle bisector goes through, it makes this angle equal to this angle, but now we're looking at a right triangle. We know the two legs of the triangle are 15 and 36. So one leg is 15, the other leg is 36. And the question is asking us, what is the length of this part and what is the length of this part? Well, the one thing we can figure out, since this is a right triangle, and I know this is 15 and I know this is 36, I can actually figure out what this length is by using the Pythagorean theorem. 15 squared plus 36 squared is going to equal c squared, the side across from the right angle. 15 squared plus 36 squared is 1521. Take the square root of both sides, and you are left with c is equal to 39. So that means this whole side is 39. If I want to figure out what each segment, the length of each of these segments are, if I know the whole thing is 39, let's say I call this segment x, that means that this segment has to be 39 minus x. So now I have each part that I need up here. If you look at this example, A would be 15, B would be x, x would be 36, and y would be 39 minus x. So now that I have all four parts, I could set up my proportion. 15 over x is equal to 36 over 39 minus x. Cross multiply, 36x is equal to 15 times 39, which is 585 minus 15x. Add 15 to both sides. 51x equals 585, and then divide 585 and 51, and you're left with x is equal to 11.47. That means that this length right here is 11.47. But the question asks you to also find the length of this. So you need to take 39 and subtract 11.47, which leaves you 27.53. So the lengths of the two segments are 11.47 and 27.53.